Let A be the matrix, real matrix of the size 3 cross 5 with rank of this matrix A is 3. For options, in first option, the system of linear equation Ax equals to B has a solution for any column vector B. If we construct a matrix A, then size is 3 cross 5 and the rank is 3, it means every row contain pivot. Every row contain pivot. If we adding one extra column known as column B, then rank doesn't alter and in each row we have pivot. It means rank of A means coefficient matrix and rank of augmented matrix both have same rank. That's why solution exists means consistent and there are 5 variable less than 5. That's why infinite solution. Infinite solution for each B. Option A is true. The system of equation Ax equals to B has infinitely many solutions for any column vector B. The system of linear equation Ax equals to B has a unique solution for any column. Not a unique solution because of rank is not same as variable. Option D, the system of linear equation may not have solution, but system always consistent whenever rank of coefficient matrix is same as rank of augmented matrix. Option D is wrong. If you construct a linear transformation T from R5 to R3, R5 to R3, we have rank of this transformation T is 3 and this is same as dimension of codomain. It means for each element for each element in codomain we have pre-image in domain. That's why this is on to and have solution for every column that exists in R3.